Okay. Let me see. That looks good. Let me check another thing. Testing, testing. That's gonna have to do. All right, all right. Let's get these guys in here. And then this, the source needs to be, we do same as system. Testing, testing. Okay. Whew. Let's go like this. We can just put you there. Cool beans. Let's rock and roll. Welcome, welcome, gentlemen. Welcome in. Sorry for the delay. As soon as I was about to I was on my way. My finger was on my way to start the stream and let you guys in. Computer crashed. I was like, ugh, technology, aren't you grand? So I had to quickly reboot everything and then reload everything and put everything back. I'm just taking attendance. As I let you guys in, we'll do some announcements, and I mean, you should have an idea what we're doing today. We don't have to do the same thing. Let me see. This is again, I just do it this way because it's kind of hard to get you guys to talk. You don't have to talk. You're not obligated. It is encouraged and recommended, but it's not necessary. Um, Let me just finish taking attendance. Hopefully, you guys are doing well. So we're done with the new material. I'm not going to be doing any more new material. Let me get these guys in before I kind of launch into it. Like I said, I'm just filling the air as I take attendance. Anybody see the movie Eternals? I saw it. I don't want to spoil it though. I probably shouldn't talk. I just realized it's probably a good amount of you guys that hadn't seen it. We got a lot of students. Okay, I think that's this one. Almost there. All right, and then like this, and this one. All right. Okay, we got another one. Did I get him? Okay, cool. I got those two. And then let me mark these other gentlemen as absent until they arrive. Come on. All these guys are absent until I see them. Let me check something really quickly. All right, gentlemen. So welcome. Let me see. So we are in the home stretch. If you are still here and you're still hanging strong, I think you'll be fine. Hopefully, can you guys hear me? I think you guys can hear me. I'm going to suppress my audio. And I feel like that looks good too because I can see you jumping. Okay. As far as announcements, so we're done with the new material. There's no more new material. This is what the end of week 14. So we only have max 2 weeks remaining because I think it's like 16 weeks. I want to say next week is Thanksgiving. That seems about right. All right. I'm assuming that we don't meet that Wednesday. I won't be mad at you if you don't show up. I had to confirm the dates, but I just haven't done yet. I more than likely will be here that Monday, and more than likely I won't be here that Wednesday. But let me just listen for me. Just wait for me to kind of say it's official that we're not going to meet on that Wednesday. Because if my supervisor's like, no, we meet on that Wednesday, then we're going to have class, right? But it's a high chance that we won't meet that day. Let me get this student right there. Let me see if there's any other announcements. So again, I haven't confirmed the next piece of information, but generally speaking, our final exam for college algebra. Okay, one thing is it's a common final exam, right? Generally, there's a departmental final, so it's going to be a little bit different than what we normally do. I think I got him already. Yeah, I remember his name. So there's a part that's required by the school, and then there's a part that I'm going to do. I got to talk with my supervisors to see the details of it. So, but the part that you're responsible for me, I'm very very tempted to make it available starting that Monday and just give you the entire week, but it'll probably lock out Thursday night at like midnight, right? So I want to make it available and give you extra time to just work on your final. You get it done, and then there's going to be another part where we're going to meet that's required by the school. So I got to get the details on that. I currently do not have the details on that. Also, another piece of vital information for your everyday life. All of our old assignments are going to lock out that Monday. So more than likely, what I'm going to have happen is everything is going to lock out that Monday morning at 9 a.m. That first Monday of December, and then but I probably simultaneously will make my portion of the final exam available that Monday at 9 a.m. So everything else is going to lock out, and all that's going to be available is my portion of the final. There's still a departmental portion that you're going to have to complete, and you're gonna have to be available that Thursday. Usually that component is released that Thursday for a few hours, late Thursday. So if you're trying to make plans to like travel, best is probably just make it for Friday. That's probably the best thing. If you're going to travel on Thursday, I just don't recommend it. You might want to leave like 10 or 11, maybe midnight, something like that. But usually the college algebra final exam is late that Thursday, the week of finals, and the week of finals is that first week of December. If anything is not clear, feel free to use the chat. I'm trying to think if there's anything else. So everything locks out that Monday. My intent is to make my portion of the final available at that Monday at 9 a.m. and it'll be due probably that Thursday at midnight. More than likely, it'll just be an amalgamation of your old exams. But honestly, your old exams are an amalgamation of the homework. So I probably will do the whole pool technique. Like it's gonna be my portion. It'll probably be something similar to the exams, just cumulative from the beginning to the end. All right. But I'm giving you extra time because every time you take my portion, it's going to change up. It's going to be questions that you should be familiar with. Like it's nothing. I'm not trying to trick you, but I can't just give it to you, right? If you are trying to boost your grade, my recommendation, if you don't do anything else to boost your grade, you definitely want to get your old exams in order first. All your exams for the semester total to about 80% of your grade. Also, for your lab component, if you have a lab, um, what I'm going to do for that is if you have a lab, whatever Dr. Lamar puts in Blackboard, I'm going to scale that to 10% of your overall grade. So whatever she puts, so if you need to improve your lab grade, you need to talk to Dr. Lamar. But for me, the main thing is get your exams on Pearson in order. That's 80%, approximately 80% of our grade. I can't think of anything else. So the labs, if you have lab, Dr. Lamar, if you're trying to improve the grade in my class, the main thing are the exams. The homework is a lot of work for a little bit of points, right? So right now, I don't really recommend worrying about the homework. I would say it is what it is. The best thing, get your exams in order. Once you feel like your exams are where you want them to be, the next thing I would target are the quizzes. The quizzes, they're only like 5 questions and they're 10% of your grade, whereas the homework is like hella questions and it's still only 10% of your grade. So instead of doing all this work for a little bit of points, to be most efficient and maximize your points, you definitely want to target. And this is across the board. Whatever grade you're going for, and whatever grade you're aiming for, you definitely want your exam grades to be higher than that. Like if I don't recommend aiming for a C, but if you're aiming for a 70 something, you can't make 70s and 60s and think you're going to get above a 70. You got to score above whatever grade you're going for to get within the proper range, right? So the way you do that, get your exams in order. That's the main thing for me. And then after me, I would definitely talk with Lamar and make sure that Dr. Lamar make sure that stuff is straight. And then from there, once we go into the week of finals, again, once we take that final on that Thursday, that's it. So nothing lingering. I think we only got like maybe a week or so for the older stuff. That Monday will be here really quickly, right? Okay. So what we're doing today, I can't think of anything else. I kind of went through it several times in my mind of the things I felt like I needed to say. So what we're doing today, we're going to be working, let's go here, on the problem set. And we'll probably take some time. I think let me do it like this. Will this work? No. Try that again. Daggone it. See, that's what I was trying to avoid. I don't even know how I did that. Okay. Yeah, I know. Hang on. Is it like this? Okay, that works. That works for me. Okay. So yeah, we're going to work on the homework. Let me just, can I refresh it or something? Let me go to the next one and come back just to make sure. Sorry, you need to exit this assignment. Okay. Let me just exit and load another one. I knew that was going to happen. Come on. And then I know you can't see it. Let me make sure it's showing here. That looks good. You guys are here. Let's share. Share. We want to share this screen and uh-oh. Did I lose my other screen? Let's try this again. Sorry, guys. Let's go here, share. There it is. This one and this one, share. Okay. Let's go here, like that, and move you. Come on. You go there. And let me make sure that that looks good. Okay, cool. I think we're ready to rock and roll. Okay. So again, like normal, I'll be monitoring the chat. If you have any questions, comments, or concerns, you need to get my attention, just use the chat and I'll stop. Or if you want me to go to a different question, I'm just working the homework set for section 6.4. We don't have to work this homework set. Yeah, but we're just going to kind of start here. Okay. So this first question, and let's see, can we make it a little bit bigger? Okay. I think this is okay. Let's shrink it down just a little bit. Oops. Okay. So which of the ordered pairs is a solution of the given system, right? So this is a terminology, right? In order for these ordered pairs to be a solution, what that means is if we plug this into the system, you know, the corresponding x and y's, it should make each of these true, right? So let's see what happens. When x is 6, so if we say 6 times 2 is 12, 12 minus 15 is negative 3. That one checks out. Negative 30 minus 30. So this doesn't work in B. It works in A, but not B. Let's try the second option. 9 times 2 is 18, plus 6 is what, 24? I think that doesn't work. So let's try C. 3 times 2 is 6, minus 9 is negative 3. It works for the first one. Negative 15 minus 18. Negative 33, right? So we're going to go with C. All I did is plug in the corresponding x and y's, all right? So just stop me if anything is not clear. If I need to go back, we're going to check that result. Or if I need to write something out, you know. Okay. Determine which of the ordered pairs. Okay, let's just do like this. A little bit smaller. Okay. Determine which of the ordered pairs from here are solutions of the following system of equations. Okay. Now, there's at least two ways that we can, there's at least three ways that we can go about this. Since they gave us these ordered pairs, we can plug and chug to see what works. I'm just going to solve using my favorite method. I'm partial to, let me look at it. I'm partial to elimination. I'm going to do elimination. So if I'm going to use elimination method to solve this, I need to take some notes. Let me go here. I like to write on graph paper, grit paper. That's good. Done. That's fine. Okay, let me take some notes. Hopefully my pen is charged. I didn't even think about charging this thing. Ooh, it's low. Okay, let me get this other cord and just have it ready. All right, so let me take some notes here. So this is question number 2. Y'all know that movie reference? Man, I just realized my movie reference jokes are like completely outdated. I totally need to update them or school you guys on some quality movies. Throwing a little bit of shade. Okay, this is question number 2. This comes from section 6.4. 6.4, question number 3, right? I see those list of options. Since I'm going to do elimination, I just want a copy of the system of equations. So we have 5x. Let me change this up because I don't like how this feels. Okay. So we have 5x minus 3y equals 7. And then we also have negative 10x plus 4y equals 12. Okay. Let's hop over to the tablet. Awesome sauce. And we want to hide everything. Cool. Okay. So this is the system that we're going to solve. I'm partial to elimination, so I'm choosing a variable that I want to eliminate. To me, it looks like the x is easier to eliminate than the y, right? Because the goal is, once you choose your variable, you want to get it, you want to use multiplication and finish with those two numbers to be the same with opposite signs. See, this one, the y had to multiply like both of them, but with the x, I only had to multiply one to get them to the same, right? So what I'm going to do, I'm going to multiply this entire row by 2, right? So that times 2, that times 2, and that times 2. Okay. Now when I do this, we get the following. 5 times 2 is 10x. 2 times negative 3 is negative 6y. 7 times 2 is 14. Okay, then we're just going to bring down that second equation, negative 10x plus 4y equals 12. Now I'm going to add these two together, right? Combine like terms, or this is just a technique for solving a system of equations. If I add these together, a number plus its opposite, these add to 0. Negative 6 plus 4 is negative 2. Okay, that's what, 26. If I want to solve for y, the opposite of multiplication is division. So I'm going to move that 2, I'm going to divide both sides by negative 2. And y equals, what is that, negative 13. Okay? So now that we've solved for y, we want to go back and solve for x. I'm going to use, these both look a little bit challenging. I'm going to use the first one because it looks a little bit easier, all right? So if I plug this result into the first one, we have 5x minus 3, but our y is negative 13, okay, equals 7. Going to bring the 7 down. Double negative is positive. What is that? 39 plus 5x. We have one equation, one unknown we can solve. If we subtract, I feel like I did something wrong because we're getting some fractions. Let me go back and check my work real quick. We get 5x equals, if you subtract, you get a negative, what is that, 32? And so we get a weird answer. Negative 32 over 5. Okay. So we got, now I'm going to go back and check this to see if this works, because this doesn't, usually it's not like that, but you know, stranger things have happened, right? So now we got a result of negative 32 by 5 and negative 13, right? I'm not confident in this, but I'm going to check it before I submit it so we know whether it's correct or not. Let me cut this. And let's paste. And let's do the following. Okay. I'm going to pull up the original. Oh, we have the things here. Determine which of the ordered pairs. Okay, so this is not even in that list. The first is the solution, the third, all. It's definitely not C, right? Okay, we got none, but we should check it. I think for the sake of time, I'm just going to use the multiple choice because I didn't even check to see if ours was correct. Let me look at one other thing. 5x minus 3y equals 7. Negative 10x plus 4y equals 12. We multiply by 2, 10, okay. Add, that's a negative 2. 14, 24, 26. Negative 13, right? Okay, I'm going to say none of these ordered pairs. I didn't check by plugging mine in. Hang on, so you guys can see. Oops, like this. So I started to plug mine in, but I realized that they gave us a list of ordered pairs. That makes me a little bit more confident in my result. I could just plug it in and be a little bit meticulous. I'm just, for the sake of time, and because we can, I'm going to go with D and see what happens. Let's see, right? So we got something different. I wasn't confident, but then when I looked at it again, I felt good about it, right? Let me check the chat real quick to see if there are any. Here it is. Okay. Okay. No. Okay. Solve the system by graphing. Okay. So in order to graph, we're going to solve for y. I'm going to go ahead and click to enlarge. These are both lines, right? The highest exponent is a 1 on any variable. So for instance, if we're focused on that first one, we have x minus y equals 5. If we solve for y, we get y equals x minus 5. So then to graph, if it's x minus 5, that means the y-intercept is negative 5. And then the slope is 1. So if we go up 1 to negative 4 and right 1, we can put a second point, right? So I use the slope to get that second point. And then for the second equation, if we solve for y, y is going to be equal to negative x plus 13. So the y-intercept is 13. Right there, 13. And then the slope is negative 1. So we go down 1 and right 1. We're going to put a point on 1, 12, right? So we use the slope to get to the second point. So now where do they cross? Can we like enlarge this? What is this? Is that 9, 4? It looks like 9, 4. Let me see. 9 minus 4 is 5. 9 plus 4 is 13, right? So then they cross at the point 9, 4. Let me hit save. I'll check the answer. So the solution, type an ordered pair, we got 9, 4. Parentheses, 9, 4. Okay. Check the chat. The chat looks okay. On to the next one. Man, time flies. We only got like 15 minutes left. Estimate the solution of the system by using the graphical method. Okay, so the second one is already, oh, are these the same? Because if you subtract 4x, you get the same, right? So it's the same graph. Y-intercept is 12, right here. And then the slope is negative 4. So if you go down 4, you're going to be at 8 and go right 1. So 1, 8 is the second point. I'm going to hit save. I'm going to check. All right, because both of those were the same graph. There are infinitely many solutions. Let me see. They take on the form, no matter what x we choose, the y is going to take on the form negative 4x plus 12. All right, basically, like if you solve for y, so when you have infinitely many solutions, the y component comes from when you solve for y. Okay, I think we're okay so far. Let me check another thing. Okay, testing looks good. Okay. Determine whether the following system is consistent or inconsistent. If the system is consistent, determine whether the equations are dependent or independent. Do not solve the system. Okay, they have different slopes without solving. So in order for them to be inconsistent, they would have to be parallel lines when they have same slope, right? With different y-intercepts. So these lines are not parallel. So it is consistent, and then for them to be dependent, it would have to be one equation would have to be a multiple of the other, and one is not a multiple of the other. So then we can say this is consistent and independent. All right. Hopefully that was okay. Let me know if I need to go back over that. Determine whether the following system is consistent. So same instructions, right? Let's see. Okay, in order for it to be inconsistent, they would have to have the same slope. So if we solve for y, is one a multiple of the other? Times 2 times 2 times 2, right? So one equation is a multiple of the other. That means that it's consistent and dependent. When one equation is a multiple of the other to the t, then it's consistent and dependent. It's going to be the same line. Okay, this is interesting. Same instructions. Okay, in order for it to be inconsistent, they would have to be parallel with different y-intercepts, right? So let's see, times 3, not times 3. So this is an example of one that's inconsistent. Because on the left here, the x and y's are multiples of each other, times 3 and times 3. But if you say times 3 times the solution, you don't get 22, right? So when part of it is a multiple and the other part is not, like this is an example of something that should be inconsistent. Okay, this is some terminology application. I'm gonna go on to the next one. Again, you got to stop me if I'm moving too fast or anything. Solve the system of equations by the substitution method. Okay, let's take some notes. This is question number 7. 7 heaven. This comes from section 6.4, question 31. Okay. Basically solve by substitution. I'm going to write that, solve by substitution. Okay. We have, let's see, we have 3x minus 3y equals negative 3. Then we have 7x plus 49 equals y. Okay. Let's hop over to the tablet. We want to hide everything. Matter of fact, it probably would have been easier like that. Boom. Okay, solved by substitution. Oh, okay. So the second equation is already, they already solved for y in that one. So we can take that y and plug it into the first equation. Okay, so if we plug that y in the second equation into the first, we get the following. 3x minus 3 times y, but y in this case is 7x plus 49 equals negative 3. All I did was replace the y in equation 1 with the y in equation 2. Okay, so at this point we have one equation, one unknown we can solve. Let me give myself a little bit more space. Again, we have one equation, one unknown we can solve. So we distribute here. We get 3x, what is that, minus 21x minus 120 plus 27, 147. Negative 3, okay. What I'm going to do, I'm going to add the 147 to both sides. Okay, and combine like terms. So a number plus its opposite adds to 0. 3 minus 21 is what? Negative 18. So that's going to be negative 18x. 47 minus 3 is what? 144. And then to solve for x, we're going to divide both sides by negative 18. Okay. X equals 6, 7. Let's see, if that were 20, 5, 6, 7, is it like 7 or 8? Maybe it's 8. Let me see. If the answer is, say we were doing negative 8, that would be 80 plus 64, 144, right? So x equals negative 8. You can use a calculator. I was just practicing some mental math. That's just x. So then we can use this x to go back and solve for y. I think in one part we already solved for y. So earlier we said that y equals 7x plus 49, but the x we got was negative 8. So then 49, 56, 7, negative 7. Okay, so we got that y equals negative 7. Okay, so we should check. Let's do a quick check. Okay, so then 3 times negative 8 minus 3 times negative 7, negative 24 plus 21 is negative 3. That checks out. And then we want to say 7 times x plus 49, negative 56 plus 49, negative 7, which is y. That one checks out, right? So the ordered pair that we got was negative 8, comma negative 7. Okay, hopefully this was okay. Okay, let's go like this. Let's see, it should be switched. One solution, we got negative 8, comma negative 7. Negative 8, comma negative 7. Let me see the time. All right, so we got a solid 10 minutes. Time flies when you're having fun, and the time's not flying, you better start having some fun. Okay, was that it? How do we get to the next one? Oh, this is the next one. By substitution, okay, let's take some notes. So this is question number 8. This comes from section 6.4, question 33. Solve using substitution. Okay. We have x minus y equals 4. Wow. And we got 6x plus 5y equals a negative 31. Okay. Let's hop over here like that and like this. Okay. So if we're going to do substitution, we need to solve for one of the variables. I'm going to solve for y in the first equation. So from here, if I solve for y, add and subtract, we'll get y equals x minus 4. Then I want to take this and plug it into the second equation. And I'm going to take this and plug it in right there. All right. Style. Okay, I'm going to replace like this. Okay. So then this gives us 6x plus 5 times y equals negative 31. But the y in this case is x minus 4. All right. Now at this point we have one equation, one unknown we can solve. So I'm going to distribute this 5, bring down my equal sign. Well, the 6x comes down. We're going to get a 5x minus what, 20 equals negative 31. Combine like terms. I'm also going to go ahead and move this 20 to the other side using the inverse operation. Okay. A number plus its opposite adds to 0. 6x plus 5x is 11x. That difference is negative 11. Divide both sides by 11. X equals negative 1. Okay. So then, let's go back and solve for y. Earlier we said that y equals x minus 4. So that's going to be negative 1 minus 4, which is negative 5. Okay. So then the order pair that we get was negative 1, comma, or is negative 1, negative 5. Okay. All right. We got about 5 minutes. Let me see. Negative 1, negative 5. Okay. Negative 1 plus 5 is 4. Negative 6 minus 25 is negative 31. Okay, so we're going to go with this result. Let's hop here. We got one solution. We got negative 1, comma, negative 5. Yeah, no, here. Go ahead and start charging this thing. No. So we got negative 1, comma, negative 5. Okay. All right. Substitution, add and subtract. I'm going to try to find, I think I'm just going to go ahead and just do this one by elimination. I know it asks for substitution, but I do want to do a little bit more showcase of elimination. This is question number 10. I see the time. It comes from section 6.4, question 35. I'm going to say 2x minus y equals 5. We're going to do 8x minus 4y equals 10. But I'm going to use the elimination method. Okay, so I want to eliminate, for me, I'm going to eliminate the x's, right? If I'm going to eliminate x, I want them to be the same number with opposite signs. Actually, let me just do the y. I'm going to multiply this row by what, negative 4? Because I decided to do the y instead. All right, let's see what happens. So if we multiply that row by negative 4, we'll get negative 8x plus 4y equals negative 20, right? You should see something. 8x minus 4y equals 10, right? So this should be inconsistent, right? If we add these together, a number plus its opposite, this adds to 0, this adds to 0. So then we'll get 0 equals negative 10. This is false, right? So when this happens, this means that this is an inconsistent, there's no solution. This system is inconsistent. These lines should be parallel with different y-intercepts. Let's go back here. So the solution set is the empty set. It's no solution. All right. Okay, let's see if we can do the next one. Solve the system by substitution. Okay, let me do this one. This will be the last one for our time. Let me take some notes. So this is question number 11. This comes from 664, question 31. We have this x plus y equals 1. We have x squared plus xy minus y squared equals negative 29. All right, I'm going to say solve by what? Substitution. Okay. Okay. So like if we can't do elimination here because of those, like the variables are different, the terms are different. So we're going to use let me check this student real quick. Y'all are bold coming in. I shouldn't even give them the credit, but it's the end of the semester, so I don't care. Okay, so we're going to solve this by substitution. All right, so let's solve for y in the first one. All right, so if we solve for y, we're going to get y equals negative x plus 1, okay? Then we're going to take this and plug it into the second one. So then we're going to have x squared plus x times y minus y squared equals, I think it's negative 29. Let me check really quickly. Negative 29. And again, the y in this case is negative x plus 1. Negative x plus 1. Okay. Okay, at this point we have one equation, one unknown. Let me see. I guess we can expand it out. Yeah, let's expand it all the way out. Okay, if we expand this all the way out, we'll have x squared. Right here we can distribute, right? So then we'll get negative x squared plus x, okay? Then we need to FOIL, first order inner last. So that's going to be x squared minus 2x plus 1 equals negative 29. We need to distribute this negative here. Okay. And we can go ahead and cancel these like terms, right? So then we'll have x minus x squared plus 2x minus 1 equals negative 29. I think I'm going to set this to 0 and solve. Okay. I'm going to move everything to the right so my leading coefficient is positive instead of negative. So then I'm going to have x squared minus 3x minus 28 equals 0, right? I just basically I combined like terms and moved everything to the right because I wanted my leading coefficient to be positive. So that's there. That's 3. You subtract, you add. Okay, this looks good. So now at this point, we should be able to factor it, right? So factor, we should be able to do something of this nature, where we have x and x. I think it's a plus and a minus. 7 and 4, right? Negative 7 and a positive 4. Notice that negative 7 times 4 is 28. Negative 7 plus 4 is -3, right? Again, this equals 0. So then x equals -4 or 7, right? So then we need to find the corresponding y's for each of those x's, right? So when x is -4, let's clean it up. When x is -4, y is going to be, we said that y equals -x plus 1. -4 plus 1. So that's 5. So that ordered pair should be -4, 5. And then when x is 7, y equals -x plus 1. So then that's going to be -7 plus 1 is -6. So the net order pair should be 7, -6. Okay. We're out of time. I need to check this. Let me see. Let's go paper. Okay. So when x is -4, -4 plus 5 is indeed 1. 7 minus 6 is 1. Okay. Let me see. 16 minus 20 is -4. -25 minus 4 is -29. That checks out. 49, 36, 42, -42. So then that's a -7. -7 minus 36. -7. Let me check that one more time. 7 squared is 49. 36, 42. 49 minus 42 is -7. 36. Okay. Is it -7 or is it +7? I think it's a +7, right? 7 minus 36 is -29. Okay, I feel good about that. I think I did it. I should have written it out. I'm just trying to rush to get you guys out of here. Let's hop back to Pearson. Okay, type in order pair, use the comments to separate answers as needed. So the first order pair that we got, and I think this other one was okay, was -4, 5. And then the second one was 7, -6. Okay. We're going to check. Okay. And that is time for us, gentlemen. We are out of time. Okay. Let me see. I can't think of any other announcements. So I felt like we talked about what we needed to. There don't seem to be any questions. So that means one of two things. Either you all completely get it or you just lost and you won't ask questions. That's usually what that means, right? If no one says anything, then either everybody gets it or everybody does not get it, all right? But anyway, I can't force it. But on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace, guys.